Hello, everyone. The topic of our presentation is electronic waste recycling. I'm the first presenter, Li Zhilai. Firstly, you may wonder what is e-waste and e-waste recycling. In our daily life, we use lots of electrical and electronic equipment, and once they are discarded and we don't use them anymore, they will turn to e-waste. But the e-waste, some components of them are still useful. So before we reuse them, we have to dispose of them. And this process, we call it as e-waste recycling. And our presentation will divide it into 7 following points. And we can see the first part of it is the definition of e-waste. The standard we are talking about is from the United Nations, and the e-waste is divided into 6 groups. The first is temperature exchange equipment. Second is the screen and monitors, lamps, large equipment, small IT and telecommunication equipment. And we should notice that this system doesn't cover any kinds of batteries accumulators. But in our presentation, the batteries and accumulations, they are all included in the e-waste. So for the next part, let's welcome the next presenter.
Dear Professor, my name is Yang Chua and my student ID is in the left corner. And my report is about the damage of e-waste. There are 3 parts in my report, and next I will introduce them for you. In part 1 is about the impact of e-waste on the environment. According to the United Nations Global E-Waste Monitor 2020 report, a record 53.6 million metric tons of e-waste was generated worldwide in 2019, the equivalent of throwing away 1,000 laptops every second, and this will more than double by 2050. Besides, with only 17.4% of the world's e-waste collected and properly recycled in 2019, meaning that 15.3 million metric tons of e-waste are placed in landfills, burned or illegally treated and disposed of in a sub-region. And effect on the air. One of the most common environmental impacts of e-waste is air pollution. If not cooked, melted, or burned properly, e-waste can pollute the air. This practice releases dust particles or toxins such as dioxins into the environment and cause air pollution. And the next is the effect on the soil. One of the most obvious ways that e-waste affects the environment is through the soil. If not handled properly in regular landfills or places where e-waste is illegally dumped, heavy metals and flame retardants can leach directly from e-waste into the soil, causing groundwater contamination and the contamination of crops grown in attachments. And next about the water. When soil is contaminated, toxins end up in nearby waters. Heavy metals from improper e-waste disposal, such as mercury, lithium, lead, and barium, can leach into the ground and even into groundwater. When these heavy metals reach groundwater, they inevitably impact streams, rivers, and lakes, and local ecosystem will be damaged. And part 2 is about the impact of e-waste on human health. E-waste contains components that are harmful to human health, such as mercury, lead, cadmium, polybrominated, flame retardants, barium, and lithium. Because of spread of pollutants, they can be present in our food, water, and the air we breathe. For example, the dioxins damage the immune, nervous, and reproductive systems, and could negatively affect the lungs and kidneys. And besides that, the children's health is a more important question that we should consider. A 2021 WHO report on e-waste and children's health calls for urgent, effective, and abiding action to protect the health of millions of children, adolescents, and mothers-to-be worldwide from the danger of informal waste disposal. As we all know, due to children's younger age, they will absorb more pollutants and be less able to metabolize or eliminate toxins from their bodies. And part 3 is about the ways to prevent and mitigate e-waste. There are 6 ways to prevent the e-waste. For example, extending the service life of electronic products, adopting clean product technology, and strengthening the law, enhance public awareness, and formulating the management norms and safety measures, and improving the recycling rate of economic products. And next, students will introduce the details of recycling. Thank you.
Hello, I'm the presenter called Li Zhilai. This is the third part of our presentation, the technical method for e-waste processing. The problem is what components should we recycle? It does matter, and the answer is the PCB, because the metal part is the most cost-effective. And in the PCB, there is a lot of precious metal. And we can see this table, although there are pretty much plastic in PCB, but the boards are still rich in copper and some precious metal. For example, the gold, the silver, and platinum, and they account for a significant portion of the all of value. So for recycling the metal in PCB, we will implement the following 3 methods. The first one is the pyrometallurgical process, and the hydrometallurgical process, and the biometallurgical process. For the pyrometallurgical process, we can see we can use the high temperature to smelt the metal in the blast furnace, and we can get the molten metal. And it's very convenient, but we can't recycle the plastic because of the high temperature. The plastic will be burnt out, and it's very easy to cause the air pollution. When it comes to the hydrometallurgical process, we can use the acid and alkali to convert solid into the solution. And there is less risk of air pollution, but what we really need is the very large volume of solution. And it can also cause the water pollution. The final is the biometallurgical process, and it includes 2 areas, bioleaching and biosorption. The bioleaching, which means the microorganisms can convert solid into the liquid, and then the metal ions in the solution can be recycled. In contrast, the biosorption process, by using microorganisms, can convert liquid to the solid. It is very simple, cheaper, and eco-friendly. But the time leaching process is very slow and time-consuming, and it can also cause the water pollution. Let's welcome the next presenter.
Dear teacher, my name is Luo. Today I will discuss the economic effects of electronic waste recycling. I will separate these parts into 3 sections: cost, risk, and market. For the initial investment, the cost of apparatus and buildings is major. This figure presents the CRT process equipment, which is used to remove the toxic metals from waste. What's more, factory construction costs are also huge compared with traditional garbage recycling. Although electronic products have a high recycling rate, it still requires large numbers of raw materials to be stored in the warehouse to obtain the scalar effect. Apart from that, research found also is a necessary cost because e-cycle technology is still not full development. For the operating cost, it's mainly consisting of equipment maintained, waste select cost, transportation, and staff service. Next is an example of Hong Kong. WEEE Park is a waste electric and electronic equipment treatment and recycling facility. Hong Kong government costs about 550 million Hong Kong dollars for these buildings. And then are the prospective benefits of economic cost. In 2019, according to the known documents and the recycling rates, a potential raw material values of $10 billion can be recovered from e-waste. Taking carbon emission limits into consideration, e-cycle is estimated to have reduced greenhouse gas emissions by up to 15 million tons. When it comes to the risk, the first one is the staff healthy. The current technology is not yet able to do the green treatment, so the emission of toxic materials is inevitable, which cause health problems to the staffs. Secondly, since many electronic products retain the personal information of the original user, personal information may be leaked during the recycling process. Thirdly, low-recycle companies mainly make benefits from government subsidies, not from the waste processing. Once the government subsidies are reduced, many companies will be closed down. Let's look at those figures. Then show that far more waste is produced than is collected. It's clear that supply is less than the demand. For competition companies, including electronic manufacturers, traditional waste recycling factory, and second-hand trading software. But on the other hand, if e-cycle companies work with them, then both sides can achieve more benefits in the green and economic fields. Finally, thanks for your listening. That's all. Next is Yang Minhao.
Thank you, Liu Nuo. Hi, everyone. I'm Yang Minhao. I will introduce laws regulations of e-waste recycling. As mentioned, large quantities of hazardous material such as mercury and platinum contained in e-waste provide a significant threat to the environment and public health. And the vast quantities of materials and valuable metals such as copper found in abundant electronic equipment can be recycled to conserve resources and safeguard the environment. In order to protect the environment and human health, governments have enacted a series of relevant laws and regulations to clarify the management for e-waste recycling. In 2017, there are 60 countries have published the e-waste legislations, and in 2019, there are 78 countries have published that legislation. With this, 71% of the world's population is covered in 2019. Next, I will describe the legislation on each continent in 2019. In Africa, 13 countries have national e-waste legislation, and in East Africa community, they have adopted a regional e-waste strategy to achieve a sustainable e-waste management system, and the strategy contains several aspects. Let's move to America. It's interesting. There is no federal law governing the e-waste in the United States, but 25 states have enacted some form of legislation. In Latin America, only a handful of nations have enacted e-waste laws. In Asia, 17 countries have published the e-waste legislation, and in Europe, they have the most countries have that legislation. In Europe, the majority of e-waste is regulated by WEEE directive, and they will be introduced in next part. In Oceania, Australia also have its own legislation, which is named NTCRS. Although the laws and the regulations governing the e-waste recycling are relatively well developed, the enforcement is a key issue, and this is an example. The example shows only Estonia and Bulgaria has reached the target, which means having the best policy and regulatory framework in the world means nothing. So more and more investor-related policies, legislation, and resulting regulations consider more upscale design and production aspects in most governments. So therefore, the definition, role, and obligations of each stakeholder need to be clearly laid out in the regulations, and this is related to the extended producer responsibility, and this is the content. Next, my teammate Li Yuan will introduce accessible cases analysis.
Okay, I'm the final presenter, Li Yuan. Let's come to the last section, recycling cases analysis. E-waste recycling is a complex process in which collection and post-processing are the most critical aspects. In these aspects, governments, organizations, and individuals are all important. The government incentivizes the remaining two components and set rules for recycling. Organizations are the mainstay of the recycling and reuse. Meanwhile, individuals play a significant role in collecting and reducing e-waste. Now let's talk about the first part, the government. The EU countries have an excellent performance in the e-waste recycling. In 2020, the EU recycled 4.3 million tons of e-waste, which far exceeds the world's average. Why is the EU doing so great? Here are two reasons. First, the EU government sets detailed legislation. The Wasted Electrical and Electronic Equipment Directive sets targets for the collection, treatment, and recycling of e-waste. The RoHS Directive helps prevent environmental and health problems caused by e-waste. Second, they have a new plan for the circular economy. The Common Charger Initiative and Right to Repair Initiative are effective in improving reusability and reducing e-waste. The second part, organizations. Apple contributes greatly to e-waste recycling. They are friendly to materials recycling. Around 20% of the metal in their products is recycled. They also develop innovative recycling technologies such as TAS, a machine that improves material recovery. Not only companies, but some public benefits organizations are also committed to reducing e-waste. In the UK, the Restart project has helped people fix over 1,500 devices, saving much e-waste. The third part, individuals. Resident participation is the key for forwarding e-waste recycling. The W3E program gives Hong Kong residents free removal services, hotline support, and the infrastructure support. These initiatives greatly facilitate individuals' support for e-waste recycling and raise environmental awareness among residents. The program is highly effective. By the end of October 2021, about 165,000 used electrical appliances have been recycled. After this case analysis, we can give some suggestions to facilitate e-waste recycling. First, the government should improve the standard and the specification system. Second, they should explore the establishment of the EPR system to extend the lifespan of the products. Third, improving incentive mechanism is important to increase the motivation of the enterprises to participate in the e-waste recycling, and can also promote the development of recycling technologies. Fourth, government sectors should increase publicity and education, and provide support for the citizens' participation in the e-waste recycling. These actions could raise awareness of environmental protection and effectively reduce the amount of e-waste. That's all about our presentation. Thanks for your listening.